So we're going to do second and zero order rate laws today. So on here, I don't know if I made a little modification. I don't know what your notes say. I just want you to do graphs of 35 and 37. 39, sorry. 35 and 39. And when you're doing these, here's what I want you to do. I want you to show all three graphs on each. Okay, so what I mean is I want you to prove with all three graphs that one of them's a nice straight line and the other ones aren't. Does that make sense? Then, I don't expect you to like necessarily put all the axis titles, but just give each of them a chart title so I know which one's zero order, which one's first order, which one's second order. Does that make sense? So, quickly then, we got our first order rate law, which we said was, ln of A equals negative kt plus ln of A naught. And we said our slope was equal to negative k. We said our y was ln of A, and our x was time. So your y was ln of A, and your x was time. Yeah, I'm not so worried about this. If it's first order, it will give you a nice straight line. Second order, it's like this. It's kind of small, hard to see. You should have your y. With inverses, so maybe not quite as easy. There's a couple things that are easier. Slope is actually just k now. So, what you would do for an Excel or Google Docs, not Docs, Google Sheets. Yeah. What you would do then, how would you go about setting up your data table if you were trying to do a graph to see if it was a second order reaction? What would you plot?
Same way, right?
So the same process, but not the same numbers.
1 divided by concentration. You don't do ln.
No, you don't do ln at all. What do you do for your x and your y? You do what?
1 over.
1 over. Yeah, so your y is 1 over A, not like it was ln of A in first order. So for a second order rate law, to check if it's second order, you're going to plot. Your x is still time, but your y is different. You have to take the inverse of your concentration, plug that in for your y, then do the same process of breaking up a graph. Okay, and here is half-life. When you guys read about half-life, I'm hoping you just understood that what that's saying is how long would it take to get half of your stuff reacted. Does that make sense?
And then it starts over again for every additional half, right?
I think so.
Because the concentration is going down.
Yeah.
So it's not getting more.
Yeah.
It's the same for like.
And that's what I think you had to do in your homework problem.
Yeah. It's the same for radioactive things. Half-life resets.
Yeah, I believe so. Yeah.
Another half-life.
Yep. Okay, so I'm going to kind of put all this up before we do a problem here. Let's do zero order here, and then we'll come back and do that problem. now put zero order over here. So this is your differential rate law for that. That seem goofy to you? Let's hear it. Differential. This is your integrated. This is your differential. Why does that make sense?
Because you don't have concentration.
Well, you do have concentration, but it has no effect. So a to the 0 power is 1. So you could change the concentration all you want, and it's not going to change the rate. Now, usually you don't find a reaction where you only have one reactant in its 0 order, but it's possible. Okay, so now here's our integrated rate law, which we get from integration and calculus. Your slope now is again negative k, but you gotta take the inverse, or not the inverse, take the opposite of that to get your constant. Your y is just the straight concentration, which makes that real easy, and your x is still time. So now we're going to be given a specific data table where we don't know if it's 0 order, 1st order, or 2nd order, and resist the temptation to just assume that if you get an R value really close to 1, that's the perfect fit. I want to see all the graphs, because sometimes you can have an R value close to 1 and it not be the perfect fit. Okay, and there's your half-life. We'll get to half-lives here in a second. Okay? Let's do this problem. You guys got this word, correct? Except for I didn't actually put in the data for you this time. So, I want you guys to fill out your data table here. Actually, is there a way we can maybe split this up? Why don't Griffin Brothers and Ryland work on the LN, and then the other 3 of you guys work on the inverse, and then we'll just trade answers. You guys hear me?
Just do the ln of the concentration.
Yep, that's what you and the Griffin Brothers did. Why isn't there a separate data table for 0 order on here? What?
It wouldn't matter.
Maybe it wouldn't matter.
Well, it wouldn't be changing. You can keep these.
Yeah, you've technically already got the 0 order one. Done? Okay, so the inverse, we get 100, 160, 210, 270, 320, 370, 415, and 481. Those of you who were doing the other ones, why don't you put that in? You didn't hear me, did you? 100, 160, 210, 270, 320, 370, 415, and 481. Get it? Okay, so for the LN, here's what it is for those of you who didn't do that. Negative 4.605, negative 5.075, negative 5.348, negative 5.599, negative 5.867. No, did I say 8? Negative 5.767, excuse me. Negative 5.915, negative 6.028, and negative 6.175. Does that agree with those of you who got them? Okay. So, what we need to do, this should say first order, second order, or zero order. We're going to do all three. And then it says what is the value of the rate constant for the reaction and what is the half-life for the reaction and conditions for this experiment. So, can I just show it to you on Excel because it's a little cleaner? What was that?
Google Sheets is a filthy tool.
Filthy tool? I mean, it's free, so of course it's not going to be quite as...
Yeah. Not flushed out, yeah.
So are we doing like 3 separate graphs for those problems, so it'll be 6 total? For
No, one graph for each. So graph for zero order.
Yeah, in our homework though we have 2 problems, so
Yeah.
we'll need 6 graphs.
Yes.
And they'll be completely separate or on the same graph?
I'll show you because, like on your test, you're gonna probably be doing something similar to this. So I'll kind of show you how you would maybe modify it to get it all in one piece of paper. Okay. Now, you don't have to do this, but a lot of times I kind of identify, you know, we're going to do zero order here, we're going to do first order here. Actually, maybe what I'm going to do is, actually, let's just do zero first. So, our time is going to be the same for all of them. So we got 0,
1800, 3600, 4400, 5260.
You look at that, like to the parentheses A1 to copy cell A1. Remember that from Dr. Brown?
okay, so we're going to say this is first, we're going to say this is second. So then we need to do zero order, just the concentrations, correct? It's kind of a lot.
And then you just copy it.
I mean, you,
Can you copy from the notes? Do you have the notes on your PowerPoint? You could copy those numbers from your PowerPoint.
well, I have these that are handwritten in.
Oh. You doing the concentrations that are already in it?
The concentrations, but I already,
You already did.
I basically down to
Yeah, I know, but you.
one left.
Yeah.
Now, I think I can do, let's see if I can do this. Oops. Let's see if I can do this. First order.
I don't know that that'll be enough.
What do you have to sign?
Well, it would be, so what I'm saying is you could do that instead of doing the ln on your calculator.
Oh,
Like,
yeah,
you see what I'm saying?
yeah.
Now, I think there's a way that I could tap and drag and get LN to work through all of them, but I don't have an expertise, super strong expertise with Excel.
I'll just do ln parentheses number.
Oh, you know what I can do? Yeah. All right.
Yeah.
Maybe it's not much faster, but
It is a little bit faster. Use count.
ah! Okay. I probably teach you how to use Excel here. Did I do that right? I feel like that's wrong.
Yeah, we did.
All right.
I'm
this
still-
stuff's
still-
But that would save you time if you were actually like hadn't already calculated what it was.
Yeah. To use a zero order, I have to sample it because it's the one that doesn't change. Just like 1 over e to the power of whatever to cancel out ln.
And you could do the same thing. You could do the inverse on Excel as well, but it's pretty easy numbers to plug in. So I'm just going to do that.
Wait, what do you have for that? You have 150 or 160?
160.
Oh, okay.
On the right?
On the projector, you're right. On the projector, it looks like 150, but when it's small.
Okay, so start with zero order. Insert scatter plot. Obviously, it's not a. I probably don't need to do this, but I do want you guys to still add a trend line in an equation. What?
I don't know what it's doing.
What?
I do not know what you're doing.
With this graph or with my mom? With my nose?
You're like laughing, and coughing, and scoffing at all at once.
Sorry.
It's fine. It's just
Scoffer.
not a bad thing.
There we go. You got that?
Not that one either.
I think so. Come on.
Oh, you had it. Okay.
No,
Alright,
anyway, figure out.
alright.
Oh, go in the box at the bottom, double click, or triple click, or that works too. Welcome to Watch Kramer, your charts.
Hey, that looks like a pretty nice one. See? Uh-oh, did it again.
You gotta get like the arrow.
Okay, so this one's the correct one, obviously. Now, if you go to like print and you preview, whoops. Do you see what I did? Do you see how I have this graph clicked? I have to unclick the graph.
Do you want us to like name
Yes, and so if you go to preview, it'll show you as it looks, it's going to be cut off. And then when you close it, it'll show where the line is. So I need to make this smaller, move it over. See now I'm in the page line.
Yeah.
Just showing you how you can get it all on one page, because here's the bottom page line. I can even take that and not even make that smaller. And yes, you will have to put, I want a chart title for everything, but you don't have to put the axis on the correct one. Does that make sense? You can get fancy, you can get a second order, and you can go up here, and you can give it a color.
Put it in Comic Sans, Web Things.
Yeah, you can put a hyperlink in here to how to be a successful businessman or woman. Okay.
I'm linking them right now, but they're printed
All
out.
right.
That doesn't matter.
So we got that taken care of now.
So
Only put the title on one or only put the axes?
You only have to put the title on all of them so I know which one's first, second, and 0. And then put the axis on the one that's correct. Make sense? I did that in like 5 minutes.
You still have to form
Congrats, he says. Okay, so then we gotta answer a few other questions. Now that we figured out which order it is. Which order is it? Second order. Okay, so it says, is the reaction first or second order? You would say second. You could say the reason why it's second order is because when you plot the inverse of your concentration, it gives you a straight line. That would be an adequate way of explaining why it's second order. Okay, and then it wants to know what the value of your K is. Well, you can just look here. Your K is 0.0613. Here's another way that you could do it. Isn't slope change in y over change in x?
Yeah. I haven't done that since geometry.
So, my second order, let's say this is my y minus, is that 100? I'm just going to show you that you can do this another way. Is that, what does that say, 6,200?
Why are you doing that?
Yeah, why are you doing the second order?
Second order,
Oh.
right? So someone quickly do that.
It's 0.06.
Okay. All right, you win. All right, so liter per mole, second. Okay, so I'm just saying, even if you don't have the stuff to be able to do a graph, you could find your K just doing old school algebra 1. Okay, and then C wants half-life. So since it's a second order reaction, we're gonna need the half-life for second order, which is 1 divided by your K, which is 0.0613, times your initial concentration, which in this case is 0.01. When you solve that, you should get 1.63. So, what does that time tell you?
What's on
Half of the reaction, or half of the reactants to be used up. Okay? Now, we got 3 minutes. I want to go back to your homework and see.
That's a half hour for half to be used up. 27 minutes.
Alright, so in C it says that this is a certain concentration, and that's when it has, this is 1/8 of the initial concentration, I think is what it says in C. Something along those lines. So 1/8 from a percentage would be 87.5% complete. Okay? Or another way you could say it is 12.5% remains. Make sense? Doesn't? I'm guessing if you take the ratio of this to your initial concentration, you would see that's 1/8 of it. Does everybody understand where that came from? If you take your initial concentration and do a ratio with this, you will find that's 1/8 of your initial concentration. Which means that 87.5% of it has been reacted, and you're only left with 1/8. Does that make sense? Okay. Well, there's a quick way and a longer way. So half of 100 is what? Half of 50 is what? And half of 25 is, which, that's that. So technically we went through 1 half-life, 2 half-lives, and 3 half-lives. Correct? And in B, didn't we find the half-life? In B, we found the half-life to be 23.3 minutes. So if we went through 3 half-lives, you should get approximately 70 minutes, which is your answer. Now, that's the quick way. The longer way would be having to use this equation, your ln of Do you have the initial concentration in this problem? Do you have the concentration you want to find the time of? Do you have the constant? Can you solve for t?
So how did you do this 1/8?
So in the problem it says that, what was your starting concentration? 2 times 10 to the what? Okay, and what's new concentration? 2.5 times 10 to the, so times 100, that should give you, I'm guessing, 12.5. So that's essentially this. Concentration you want, initial concentration. And that's how you're essentially using your half-life to be able to find what your time is. Okay?
Gettysburg?
You gonna make it to the game
What do you
today?
mean? It's so.
You gonna actually go to the game today?
We've only been watching it for 5 days today.